Hello everyone, this is the video lecture for Pre-Calculus 3.6, Rational Functions. Another way you could say this is fraction functions. Yep, that's not a technical term, it's actually rational functions. But fraction functions makes more sense in my mind because f of x is equal to a top and a bottom. And I'm going to be using this criteria, this style here for the rest of the section. Whenever I say something like bottom equals 0, top equals 0, that's what I'm referring to, is this guy here. I think jumping right into it, this is again review from the algebra class, but I'm going to just do the first question as a review because I think it's a pretty good one. So r of x is equal to 1 over x plus 3. They want the domain and range, let's graph it and all that kind of stuff. So first off, I'm going to ask, do we have division? And you would say yes. We do. So then I definitely want to check when the bottom is equal to 0. X plus 3 equals 0. Move the 3 over. X equals a negative 3. That's my vertical asymptote. And so I can already start graphing this. Negative 3. Vertical asymptote. I'm going to just give you a little hint. The horizontal asymptote's at 0. But again, I'll show you that here in a second. It's called the 3 rules. And then we graph it. Something kind of like that. Okay. So there's a graph of a rational function. Awesome. Looking at that graph, and from what we already see here, what's my domain? Well, I know that I can't use negative 3, so I'm going to go around it with a union. What's my range? Well, looking at the graph, I got everything negative, I got everything positive, but not this 0. In fact, I'm going to ask you, when is the top equal to 0? Come on, when's the top equal to 0? When is 1 equal to 0? It's never. So there's no zeros. There's no x-intercepts. And that's already telling you that we will never be touching this line. It might be a horizontal asymptote, I don't know. But certainly the range is saying that we're not going to ever touch it. So negative infinity all the way to 0, union 0 to infinity. And those are your two answers. Here, I'll box them in for you. I don't know if they wanted the graph or not, or if they provided it, but regardless, there you go. That was a fun little intro problem. Onward to the next one. Here we go. 36023. So I've got t of x is equal to x squared minus 2x minus 15, all divided by x minus 8. Notice again, top, bottom. So when I go through and show you what all this problem wants, because it wants a lot, I'm going to refer to top and bottom separately, individually, and in certain places. So first off, they're saying find the x-intercepts. Find the zeros. The same thing. Well, how do you do it? Top equals 0. The top equals 0. So I'm going to say, oh, okay. When is x squared minus the 2x minus 15 equal to 0. How do I find that? Well, I'm going to factor if I can. I think it's factorable. So I think it's like 5 and 3, negative 5, positive 3. Yeah, that should work. So then I got x equals a 5 and x equals a negative 3. And these are zeros. These are x-intercepts right here, okay? I can't remember exactly how they're wanting you to put it in, but I'm going to guess just a single box. They might say like bigger and smaller. I don't know. But regardless, you got your math answers. Put them in the way you need them to be put, you know. Okay, so then Y-intercept. Notice again that it says x-intercepts, plural. Y-intercept, singular, always. How do we find the Y-intercept? Well, you're going to plug in x equals 0. So like basically f of 0. Well, I guess it's t of 0, I suppose. T of 0. So plug it into 0 into all my x's. We got 0 squared minus 2 times 0 minus the 15 all divided by 0 minus 8. Honestly, you know what you could do? Floop, floop, floop. There you go. Two negatives cancel, make a positive. But, you know, I would have done that anyways. 15 over 8. And there you go. Pretty easy there. Okay. Oh, yes. Okay, now I wrote down what the WebAssign actually wants. So here we go. So we got our math answers. This is what WebAssign actually wants. I'm glad that I wrote it down. They say X-intercept smaller, X-intercept larger. Now you know you got two of them. And then they say Y-intercept. Now, the weird part about this in particular is that they're also wanting it in ordered pair form. So X comma Y is equal to blank. X comma Y is equal to blank. And X comma Y is equal to, you guessed it, blank. So, how do I answer these guys? Well, I know that negative 3 and 5 are going to be my answers, so I'm going to say negative 3 comma 0, 5 comma 0. And this guy, X was equal to 0, and then Y, or T or whatever, was equal to this answer. Notice the way I put the zeros for Y, rather here the zeros for X. That's your answers. Okay, next one. 3, 6, 0, 29. So I'm pretty sure they give you this graph to begin with. 1, 1, 2 has a vertical asymptote. 2, vertical asymptote. We got a horizontal asymptote at 1, I think. Then they got a graph, and more of a graph. So this one's kind of weird. It actually goes through this and then back down. Okay, doesn't actually touch. Cool. So from this graph, what are my x-intercepts? And I think it's the smaller and the larger one again. That kind of stuff. Find the y-intercept. I'll show you about that one here in just a second. That's kind of a little weird. And then they got some more stuff. Let's just talk about these guys for just a second. X-intercepts are pretty easy right here. We've got a negative 1 here. We've got a positive 1. So I'm going to say negative 1, comma 0, positive 1, comma 0. Again, if they're saying smaller, larger, they're saying more negative and more positive. So when they, just so you know, smaller means negative, larger means positive. Not necessarily. I'm saying the most negative or the smallest positive, rather than larger is the biggest positive or the like least negative, I guess. If that's all confusing, just left and right on the number line, left and right. How do you find the y-intercept from just a graph here? I don't know. It looks like it's at 1/2. Well, technically, this is at 1/4. I just didn't graph it very well. So you would say 0, 1/4. How do you know? Well, you just have to look at the graph. Okay, I know that kind of seems weird, but like there's grid lines all over the place, and you're like, oh, it looks kind of like 1/4. Do the best you can on that. That's just one of those like kind of problems. Not really a fan of that. Okay, vertical asymptotes. Asymptotes. This is an awesome one here. Here we go. You ready? Negative 2 and 2. No. Close. You're right. It's negative 2 and 2 right there. X equals a negative 2. X equals 2. Anyways, horizontal asymptote is this guy right here at 1, I believe it's 1. Yeah. And again, they don't want just 1. They want y equals 1. Very, very picky for that. Okay. I guess I'm like assuming that y'all know about asymptotes from the algebra class. And I do hope so. I'm not trying to assume too much. Certainly we're in the review sections right now. We will not be in them much longer, and I will not be assuming a whole lot, okay? But right now, it's still kind of basic. This is, it's kind of math that we've done a few times. Asymptotes, you just can't cross them, that kind of thing. And I will revisit the horizontal asymptote here in just a second, okay? So R of X is equal to this guy right here. They want to know what's the vertical asymptotes and then the horizontal asymptotes. Or horizontal asymptote. Notice again, plural, singular. Actually, it's pretty important distinction. Vertical asymptotes are super easy. They're always when the bottom is equal to 0. So vertical asymptotes, bottom equals 0. Okay, so then I got x to the 4th minus 1 is equal to 0. X to the... you know what? There's a few ways to do this. Actually, I'm going to factor it. X squared minus 1, x squared plus 1. I don't know if you would have wanted to factor it immediately, but I'm factoring it so that I can understand all the numbers, the multiplicities, and all that kind of stuff here, okay? So I'm just being extra careful, let's just say. Extra careful. You do not need to do this. You'll see your answers, you're thinking what your answers are from this. You're probably right. I'll show you those in a second. This guy factors down to x minus 1x plus 1. But this guy is imaginary, and we're not in that section anymore, so I'm going to leave him alone. We get x equals 1 and x equals a negative 1. It's kind of a joke that we're not in that section. You should always be looking out for that stuff, but a vertical asymptote must be a real number. So these are my answers here, and I'm actually going to be putting them both in here. You probably guessed those answers by just kind of looking at it. What could you do? You can move that 1 to the other side and fourth root it. Because it's an even root, you have to have a plus and minus. That's all. This is super easy. So you were probably right. How do you get this horizontal asymptote? So far, they've just been giving it to me, or I just kind of tell you. Well, the horizontal asymptote comes down to the 3 rules. And this is just a reminder, because this is one of those off-brand kind of things. Like vertical asymptote, a lot of people kind of remember bottom equals 0, but the 3 rules is like, what? What were you talking about? Once I tell you, it'll make more sense. So rule number 1, if the degree of the top is less than the degree of the bottom, again, remember that we're always talking f of x has a top and a bottom, okay? So if the degree, the biggest power of the top, is less than the degree of the bottom, then what do you got? A horizontal asymptote at, it's the at sign, y equals 0. That's your answer. Does this apply to this one? And I would say yes. Look, we got a 2 degree and a 4 degree. 2 is less than 4, so automatically y equals 0. Done. Like, that was it. Super easy. Let's continue the 3 rules just so that we're all on the same page here. So what if you have the degree of the top is equal to the degree of the bottom? Well, then what you actually have is a horizontal asymptote at y equals, and this is kind of weird here, I call it the front fraction. The front fraction. Let me just give you an example, since we already had one for the other guy. Just going to make something up here, if that's okay. 3x squared plus x minus 1 divided by 5x squared plus 7. There you go. Notice that we have the same degree in both the top and bottom. The biggest power on both the top and bottom are the same. And so I'm going to take the front fraction, just as you probably guessed. So that's your answer. That was pretty easy, right? Number 3, what if the degree of the top is more than the degree of the bottom? This is the best answer. I love this one. There's no horizontal asymptote. You're done. That was it. Nothing to do there. Just a quick example, just so that you know. We got a cube, x, 1, I don't know, we got a square, x, 2, I don't know, it doesn't really matter. 3 is in the top, 2 is in the bottom, none, no horizontal asymptote. But now, it is kind of interesting because what you'd have in this particular case is you would have a slant asymptote. Asymptote. Hopefully I spelled it right. Regardless, I don't know if that's going to even come up. If it does, that's fine. But it's not one of those leading things that we have to always watch out for. Okay, so I would not really worry too much about slants right now. If they talk about them later, we could talk about them later. Okay, right now just say no horizontal. Okay, because a horizontal is not a slant. A slant is a little different. Okay, glad we reviewed that. So the next one, r of x is equal to 3x squared plus 6 divided by x squared minus 2x minus 3. Okay, they want the same thing. They want everything. X-intercepts, Y-intercepts, vertical asymptotes, and all this stuff. So X-intercepts. Let's kind of like do this as the final version. This is when your top is equal to 0. 3x squared plus 6 is equal to 0. I'm going to say it doesn't ever happen. So none, DNE, I don't really know what they're wanting you to type in there. But basically, ain't nothing happening for that guy. The Y-intercept, singular, is when you plug in 0. And again, if you remember how I did this, I basically just canceled out all my x's, and I just looked at those guys right there. I don't want to leave that like that, but you get the kind of the point. I'm going to get a 6 over negative 3. This is a y equals. And so that would be, what, negative 2? So I'm just going to say y equals negative 2. Oh, they wanted in point form. So happy that I actually write what WebAssign wants. There you go. Vertical asymptote. How do we find that? That's when the bottom is equal to 0. Again, we're doing all the rules all at once. So x squared minus 2x minus 3 equals 0. I believe that we can factor this guy. X minus 3, x plus 1. So we get x equals a 3 and x equals a negative 1. These are my vertical asymptotes in the box. Remember that you need the equations. They're very picky to write the x equals stuff in there with a comma. Horizontal asymptote. That's my 3 rules. So if you go back and look, we got a 2 and a 2. They're the same, so I'm going to want the front fraction. Front fraction. So that's going to be y equals 3 over 1, y equals 3. That's your horizontal asymptote. Okay? Graph it? There's like so much here on this problem. I'm trying to like, what are we having to do here? Yeah, that's fine. Okay, so like we're gonna graph it, and if you need to use a graphing utility because it's like a bazillion steps to make this thing work, I mean, I'm understanding. I'm not wanting to get you too far off base here. You know what I mean? So we got vertical asymptotes at -1 and 3. That's a good start. We got a horizontal asymptote at +3. And what this does is kind of create like a grid kind of for me. It shows what where I could have graph at all. You know, it's going to obey this mostly. I have no zeros, so I'm never touching this thing. But my y-intercept is a negative. What was this again? Okay, hold on. Yeah, -2. Yeah, sorry. Should just scroll up. -2, right there. So my y-intercept is a -2. I'm for sure right here. I'm never crossing this thing, okay? Just make sure about that. If I'm right here, for sure that I'm going to have a graph this way. There's something going on here. It might not even be the maximum there. I don't really know. It might kind of do this. Whoa. Might do this. But that's fine. So we got something going on there. That's cool. What else is going on? How do I know the rest of the graph? I'm going to be honest with you. If you make a table, you'll at least kind of get a ballpark of what's going on. So notice that's 3. What about 4? What's going on at 4? And so if I plug that 4 into the original, and I'm just going way back to the original and plugging that into my fraction here. I didn't actually do this on my paper. I just kind of went to it. Let's find what that humongous thing is anyways. 16 minus the 8 minus the 3. I got 10.8. But notice here, 10.8 would be, well, that's 3. 4, 5, 6, 7. You get the point. So basically, it's way up high. It's going to be somewhere up here. I don't know exactly, but it's going to look something kind of like that. Okay. And then last, how do I know what's going on over this side? That's a very good question, honestly. Because I'm looking at the final graph, and it's kind of scaring me just a little bit. So what I want to do is I want to try a humongous negative number. I want to try like -10, and then I'm going to show you some other numbers in just a second, okay? So I'm going to plug in -10 into my graph the same way I did that, which shouldn't be too hard, hopefully. Minus 2, 20, minus the 3. And I've got here 2.615. I like that. That's great. Okay, now pause for just a second. Let me do one more number, and then we're going to talk about it. Let's do -2. So -2. I'm going to square it to make a 4 there. And then I got a -2 times the -2 is going to be a 4. Excellent. Excellent. That's exactly what I wanted. 3.6. Okay. 3.6 is going on right here. And in fact, that's very doable. That's not like my previous 10s. 2.6 is like way out over here. I don't know. 3, 4, 5, 6, 7, 8, 9. Where you get the point. It's like way over here. And 2.6 is about right here. Big pause. Big pause. Okay. Normally, these graphs stay within their bounds. Think of those asymptotes kind of like fences. So, generally, they're going to stay within the fence. You can see that with the ones we already got. This guy's staying within his fence. This guy's staying within his fence. No problem there. But, in this particular case, it doesn't look like they're staying in the fence. There's one continuous line over here. There's not two of them. So, what happened? What's actually happening is it starts up high. It has to follow this line here. There's no getting around that. And it's actually going to cross through the fence line at some point, come back up, and then get really close to this fence as it keeps going. Okay? So there's actually a point here where there's like a local minimum, just like over here there's a local maximum. Kind of a strange thing. I don't know where this minimum and maximum are. I don't know. But I do know that it's coming down and it crosses through the fence right there. That is okay. It doesn't happen often, but it is okay to go through a horizontal asymptote. Think of it like a fence with your dog. So your dog stays in the fence, right? But sometimes there's a hole in the fence. Could your dog get through that little hole in the fence and then run to the neighbor's yard? Well, yeah. And so there's some fences have little holes, and sometimes they'll just pop right through. Not every fence has a hole, but occasionally that happens. So there you go. That's my real-world analogy, I guess you can say. They're wanting a lot more stuff, I think. There's like all kind of stuff I have included here. So domain is going to be negative infinity to the -1, union -1 to the 3, union 3 to infinity. This is from my vertical asymptotes. That's all it really is. My range is kind of interesting. And again, I think I have to use a calculator to do this part. Let me just give it to you, and then we're going to talk about it here. So I got a -1.8, and then here I've got a 2.5. Okay, so what's going on here? This guy right here is at a height of -1.8. Okay, this guy is at a height of 2.5. So those are those two numbers that they're getting there. So how would you get those numbers without a calculator? Impossible, honestly. I guess you could try to plug in some numbers and whatever, but I would definitely recommend using a calculator on this guy. Again, you're thinking, oh man, I can't use a calculator because it's not allowed on a test. We kind of talked about this. Use it on the homework. That's fine. Don't use it as a crutch, but use it as some help. You know, there's going to be questions on the homework that require a calculator to some amount. So there you go. And again, I wouldn't think that this is on an exam necessarily if you have to use a calculator. The exams are well designed for you to use the appropriate calculator at the appropriate time. Okay, but we already talked about that. I'm going to move on. Again, if you don't know how to use a calculator, min and max features, that would be on a TI 83, 84 Casio, stuff like that. There's a minimum and a maximum like button or feature or something like that. And that's cool. Desmos is super easy. When you graph it, you just click on the thing that looks like the hill top or the valley, and it'll just give you the number. Super, super easy. So I'd recommend Desmos for sure there. I'm not going to show you. I'm just going to figure that you can do that because it's very simple to use. And I'm sure that there's like a ton of tutorials on YouTube about how to use Desmos. There's like all kind of features in there that I don't even know about. I'm just telling you the basics. Okay. Another question. We got this right here. Oh, they are talking about slant asymptotes. Very good of them. Okay, so we are going to talk about slant asymptote because they're wanting to know what is a slant asymptote here. This is actually super easy. And this particular question's weird about it, but I still want to show you, and it'll be simple as we continue on through the rest of class. Very simple here. So here's your formula for slant asymptote. When they ask for one, you assume that there is one. That's the biggest thing to note, okay? Like, if they don't say anything about a slant asymptote, forget it. If they say there's a slant asymptote, then we need to do something. Here's your formula. Division without remainder. Division without remainder, okay? Notice I'm not saying long division. I'm saying division. Notice I'm not saying synthetic division. I'm saying division. So it could be either or. Now, I personally want to use synthetic anytime possible. I don't want to use long division at all. But maybe you are someone who likes long division. So you can use long, I'll use synthetic, and we both get the same answer because it's without remainder. Whatever your remainder is, just get rid of it. Everything else, that's what you keep. That's simply it. I want to do this problem with you, but I want to do a different problem with you first because this one's a little different than other ones. So let's do my own little example on the side for just a minute here and show you what's going on. I'm just going to make up numbers if that's okay. So let's say we got f of x is 3x squared minus 5x plus 8 divided by x minus 2. There you go. Well, first off, I'm going to divide this thing. Notice that we have this 2 in the bottom, x equals 2 in the bottom. That's what I'm going to be using for my synthetic. So 2, and then I got a 3, negative 5, and an 8. So then I got 6, we got a 1, a 2, and a 10. Well, get rid of that remainder without remainder, okay? So what are we left with then? Remember, this is an x squared. Now this is a plain old x. We got then y is equal to 3x plus 1. That is your answer, even including the y equals. You must include it in part of the equation, okay? So that's my example on the side. Very easy, not too bad. We got this. Now let's do it for this guy. I'm going to ask, before we keep going, what's the 0 from the bottom? Remember right here, we solved for it, right? It was 2. That's super easy. Solve for x, right? Solve for x here, what do we do? Well, it actually is x equals 0. If there's not a number, then it's not a number. Well, kind of. So x equals 0. So we got 0 in our position for the synthetic division. It's very weird, but it will work. Now let's go very slow with this. It's the easiest one ever, but we're going to go very slow with it, just in case. 0 times 1 is 0. Negative 2 plus 0 is negative 2. 0 times negative 2 is 0. And negative 48 plus 0 is negative 48. Now remember that we're getting rid of our remainder. We don't need that. So whatever's left over, y equals 1x minus the 2. You can leave it just like that if you like. That's your slant asymptote. You're done. That's it. Not too bad. I have one last question, and this is one of those oddball questions. You know, I don't want to give it away, but I mean, this is just not... it's something that you need to know. Some of these problems actually have names for me. I call this one the rabbit problem. The rabbit problem. So I might reference rabbit problem later. I don't know. I can't remember. But this is the rabbit problem. If I give it a name, it's important. Do you understand? That's what I'm trying to tell you right now. If I give it a name, it's important. Okay. P of t is equal to 2000t divided by t plus 2. Okay. What they're talking about is rabbits, making more rabbits, and population growth, and all that kind of stuff. I'm going to tell you that I don't know exactly what it has. I'm pretty sure there's a graph, and if they don't have one, I can create one very quickly. 2,000 is actually your upper limit, this number right here. And so what happens is that these rabbits grow until they reach 2,000, and then it's too much. That's the end. Think of it like there's a big field of grass, and so the rabbits keep making more rabbits because they have plenty of grass. Well, at 2,000 rabbits, there's just not enough grass anymore. They capped out, and so that's it. 2,000, that's their cap. So they're going to ask in the problem, hey, what is this approaching? Or it approaches what? How many rabbits? And it's approaching 2,000 rabbits. Okay? That's super easy. Y, and they're going to talk about horizontal asymptote, and you're going to say it's at 2,000. I think you put in the equation. I can't remember. Anyways, look at the top number right there, 2,000. You can actually do the math very simply because horizontal asymptote, I'm saying, hey, what rule applies? The 3 rules, right? Well, it's a 1 and a 1. They're both the same. Front fraction at y equals 2,000 over 1, which is your 2,000, which is your 2 answers. Very simple. Okay, that's all I have for all of Chapter 2 and 3 put together. So isn't that nice? Have a great day, and thank you for watching.